So the last section, 5.7. They have wide applications, differential equations in physics and a lot. Okay, we're just going to get a minor taste of it. So first of all, what is a differential equation? It's an equation that has, and I'm going to copy one because I want to do something with it. So I'm copying from page 509. I'm copying problem 10 on 509. And that is y double prime. What does this mean? Excellent. Minus 2y prime. What does that mean? Very good. Plus y equals 0. This is a differential equation. Why is it called differential equation? Because it has derivatives in it. Okay, so our first endeavor here is show that y equals e to the x plus 3x e to the x, they say, is a solution. Of course I copied from a different problem. Why, are you surprised? No, I'm not surprised. I copied from 9 instead of from 10. Negative 2x e to the x plus x e to the x. We can do 9 as well. But just make sure I copied. Yes, I did copy from the same problem now. Are you proud of me? I do that. Doesn't happen often, but it happens quite enough. Okay, so we're given a differential equation, and we are told, here is the function. Show that whatever you need to do, when you plug everything in here, you get 0. Okay, I have this piece. It's right here, but I don't have this, and I don't have this. So then what do I have to do? Exactly. Let's do it. So y prime, can anyone dictate? Very good. Plus. This is a product. We have to use the product rule. So the first function prime is 1, e to the x, plus the first function times the second function prime. We combine like terms. These two are like terms. So y prime equals negative e to the x plus x e to the x. Now I can say I have this and I also have this. I have these two. Now I'm looking at y double prime. Can anyone dictate? Y double prime. Negative e to the x plus x prime is 1 times e to the x plus x times e to the x prime. Now I have all pieces. I just have to put them together in that exact order, multiply y prime by negative 2, and see that I get 0. If I don't, I'll say, assuming all my calculations are correct, I'll say no. This is not a solution to the differential equation that was given to us. So the second derivative, x e to the x minus, I have to multiply by 2 all this with minus 2. Minus 2 times negative e to the x, positive 2 e to the x, minus 2 times x e to the x, minus 2x e to the x. So I put this and this. Now plus y. Negative 2 e to the x plus x e to the x. Let's look carefully. If the answer is 0, then I'll say the given solution is correct, is indeed the solution of the differential equation. If I don't get 0, then I'll say, oops, nope, doesn't work. You get 0. I get 0 because these two go away. And this plus this is 2, and it will go away with these two, and the answer is 0. So I will say yes, it is. Should we choose another? Yes?
Sure.
Very good. Any preference? We are looking at 1 through 14 on 509.
Can we do 8?
Let's do 8. Show that in number 8, we have y equals x natural log x minus 5x plus 7, if I'm not copying from something else. And we have y double prime minus 1 over x equals 0. So they are giving us y, they're giving us a differential equation, and they're telling us, show that this is a solution. This is part of the equation. I cannot do anything. So I only have to determine the second derivative, but I can't find the second derivative before I find the first. So can anyone dictate? Please don't disregard products.
1 over x.
Careful. X prime is 1 times natural log plus x times
1 over x.
perfect minus
5.
perfect. But I have to simplify, and this becomes 1. So y prime equals natural log of 1 minus 5, which is minus 4. So I found the first derivative. Now let's find the second derivative. What is the second derivative?
1 over x.
Indeed. So plug in 1 over x in here, minus 1 over x. What do you conclude?
It's true.
Yes. So 1 over x minus 1 over x is indeed 0.
But it says double prime.
Yeah.
Double prime is negative 1 over x.
Why? When we differentiate natural log, we don't get negative 1 over x, we get 1 over x.
Right.
So this is replaced by 1 over x. 1 over x minus 1 over x is 0 indeed. Better?
Yeah. I thought it was asking me to say.
No. We are asked to show that the solution y is a solution of y double prime minus 1 over x equals 0. Is this clear? Perfect. Okay. Now we are ready to solve differential equations. We were not solving here. We were just checking whether a given solution is the solution. We did not solve differential equations yet. Okay, let's start with simple situations like 35 through 42. 35 through 42 and page 510.
39.
39 it is. 39 says dy over dx equals 2x over y. Solve. Okay, first of all, let's understand what we're trying to find. You remember we had 2 examples in which we're told, here's a function, show that it solves the differential equation. Yes?
So this is saying f prime is 2x over y.
Perfect. However, if I change it to f prime, I will not be able to solve.
Because you have x and y.
I need, exactly,
Okay.
because I have x and y on the other side. Excellent. Okay. So coming back to what we just did, we were given an equation that had either the second derivative in it and the function, or the first and the second and some other function. Show that this equation or this function solves the differential equation. Now we are given a differential equation and we want to come up with y equals blah 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 blah. So we are after y. We want to solve for y. Now what happens here is I don't know how to proceed if I have both x and y on the same side.
You have to multiply by dy.
So if I cross multiply, I get y dy equals 2x dx. Would you agree with this? Y times dy equals 2x times dx. Okay. Now, I am going to integrate both sides. Remember how I applied differentiation, or we differentiated both sides when we could not determine the function, but we were asked to find the derivative, and we did that implicitly. We differentiated both sides. Same thing now, but it's a different operation. We integrate both sides. Why do I integrate? A function times dx. The setup is clear for the integration. A function times dy. Setup is clear for the integration. Good. So now forget about this for a moment. Don't even look. And tell me, what would you write for this? You have to say y squared over 2. It's a mandatory step. Now let's say I take the x outside. What would you tell me to write for this? And you have to say x squared over 2 plus a constant c. Now you can say, wait a minute, where's the constant on this side? It doesn't matter. We don't need to put a constant on both sides. One time is good enough. Once is good enough. I will simplify. So then I have y squared, multiply both sides by 2, equals 2 x squared plus c. I'll say y squared equals 2x squared. And if I multiply 2 by c, I can say it's c1.
Or can it be,
2c.
yeah, 2c?
Because 2c is another constant. And I denoted it by c1. It doesn't matter. You can still keep c. 2 times c is still a constant.
But would you want to be wrong if we put 2c?
No, but we rename it. We normally rename it. Ready? So now we are solving for y. How do I solve for y? Very good. So plus or minus square root of 2x squared plus c, or c1, it doesn't matter how you want to call it. Very good.
Would this be incorrect if you had y equals plus or minus the square root of 2x squared plus 2c?
No, but we don't write it like that. It's not incorrect, but we don't. The constant is considered constant. With a 2 in front, with 1500 in front, with 0.2 in front, it doesn't matter. It's a constant.
But the concept of c being, let's just say, from y squared was 1. Because
It
we're
doesn't matter when you
multiplying it by two,
differentiate
it's
the,
changing.
but when you differentiate the constant, if you differentiate both sides, the constant will still be 0.
Okay.
If you write 2c or 10c or c1 or c squared, it's not going to matter. It's still a constant.
So it's still 0.
It still will be 0.
Okay.
Yeah. But it's not a mistake. Ready for the next problem? This is how we solve differential equations by separating the variables. Of course. By separating the variables. That's what we did. We had y alone on one side, we had x alone on the other. Separating the variables. Okay. Do I get to choose the next?
Sure.
36. On the same page, 510. I know I have 3 minutes. It will be the last one. So dy over dx equals 5x to the 4th times y. Oh, I wanted to pick one with a condition, but that's okay. We'll do that on Tuesday. And then we can look at some more problems. Okay. We're asked the same question. We have to find the function that solves the differential equation we see here. What do you think we have to do? Divide both sides by y, multiply both sides by dx. we are separating the variables. But I cannot just move them. I have to divide both sides by y because they're multiplied, and I have to multiply both sides by dx to have dx on this side, together with 5x to the fourth, and have y on the other side. Of course, this is ready for integration. Which function prime is 1 over y? The absolute value of y, very good. And this is 5x to the fifth divided by 5 plus a constant c. How do I solve this? This is slightly more difficult. Let me refresh your memory. Log base a of x is y can be changed into an exponential equation as a raised to y equals x. I don't want to rush through this. I know I only have 1 minute, but we'll probably have to redo this problem on Tuesday. So the base here is e. So I have to change this equation from natural log of the absolute value of y as x to the fifth plus c as e raised to this equals the absolute value of y. E raised to the other side equals this. So the absolute value of y will be e raised to x to the fifth plus a constant c. I'll stop here only because I have to show you how to separate this into another constant and how to solve this equation. Because when the power is the sum of two terms, then this is e to x to the fifth times e to c. But I have to refresh your memory on that property. And then call that constant